Hello everyone, so today we're going to go over section 6.2, the unit circle. So suppose we have the point xy be on the circle with center 0, 0 and the radius of r. We know that the x coordinate is x and the y coordinate is y. So for any point on the circle, we have the following relationship, and that is x squared plus y squared is equal to r squared. Since these three sides make a right triangle. Notice that this is also the case if x and y are negative. So in quadrant 3, this will also hold. Since a negative x value in quadrant 3 and a negative y value in quadrant 3, if they are squared, will still give us x squared plus y squared equals r squared regardless. So the equation x squared plus y squared equals r squared is the equation for a circle with radius r centered at 0, 0. In particular, if the radius is 1, then we simply have x squared plus y squared equals 1. Okay, that's once again x squared plus y squared equals 1 is the unit circle. Where r equals 1. Okay. So using this information, we can write equation of a circle with any given radius and have its center be at 0, 0. For example, if we're looking at the unit circle with radius 9, we simply have x squared plus y squared equals to 81. And if the radius is root 5 units, then we'll have x squared plus y squared equals to 5, since root 5 squared is 5. Okay. Another way to work with the unit circle is to look at points which lie on the unit circle. So we have a couple of points here, A and B. And the way that we find whether the points are on the unit circle is by substitution. So we start with x squared plus y squared is equal to 1. We can now substitute in negative 5 over 13 for x. That will be squared, of course, plus 12 over 13 all squared. And if that point, negative 5 over 13, 12 over 13, is on the unit circle, then the two sides of the equation should equal. So we have 25 over 169, and then we have 144 over 169, and that, of course, is equal to 1. So the point is, in fact, on the unit circle. Okay. The second point here, we have 5 over 6 and 1/2, so same kind of idea. X squared plus y squared equals 1. Then we can substitute here 5 over 6 squared plus 1/2 squared. And we can see that this is not going to be equal to 1 since we have 25 over 36 plus 1/4. And if we write this under common denominator, this will be 25 over 36 plus 9 over 36, which we know is not equal to 1. So this point is not on the unit circle. That's a no. So a related question is in example C. Here we're given only the x coordinate. We are to find the y coordinate if the point is on the unit circle and that it is in quadrant 3. Okay. So in this case, once again, we start with the unit circle x squared plus y squared equals to 1. We then substitute in negative 2 over 3. That will be squared plus y squared equals to 1. So, of course, when we square, we get 4 over 9 plus y squared equals to 1. That means that y squared is going to be equal to 1 minus 4 over 9, which is 5 over 9. And if we take the square root here, we have y is equal to positive or negative the square root of 5 over 3. And since the point is in quadrant 3, we'll only keep the negative square root. So this will be negative root 5 over 3. And that's because this is supposed to be in quadrant 3, where both x and y are supposed to be negative. Okay. Next, we're going to look at a couple of special triangles and how they relate to the unit circle. So the first special triangle is the 45, 45, 90 triangle. So the two angles here are 45 degrees each. Okay. And the angle at the base here, this is going to be 90 degrees. So it's a right angle triangle and also an isosceles triangle. Of course, we can also add in here the radiant measures. So we will have pi over 4 here as well, and 90 degrees is pi over 2. Okay, so since we're working with the unit circle, we're going to set the hypotenuse to be equal to 1. So the idea here is that we have x squared plus y squared equals to 1, the unit circle. These two sides, the two legs of the right triangle, are equal because of the fact that the triangle is isosceles. So we really just have 2x squared is equal to 1 here. So x squared is equal to 1/2, and x is therefore equal to 1 over root 2. Okay. Since we're looking at a triangle's lengths, we're only going to keep the positive square root, so 1 over root 2. Or, if we were to rationalize the denominator, square root of 2 over 2. So, these are the two sides, if the hypotenuse was 1. Okay, the other special triangle is the 30, 60, 90 triangle. So, kind of looks like this. This is 30 degrees. This is 60 degrees here. And the right angle at the base, 90 degrees. And the reason why this equilateral triangle is drawn next to it is to show where some of the numbers are coming from. So suppose this is an equilateral triangle, then we have 60 degrees, 60 degrees, and 60 degrees on all three angles, and all the sides will be the same length. We're going to let that length be equal to 1. And what happens is we'll end up cutting this triangle in half, like so. And of course, this will be a right angle. So notice that since the base is cut in half, each side is only 1/2. And because the angle is cut in half, this is 30 degrees on each side. So this is 30 degrees to the right here and 30 degrees to the left. So really, the 30, 60, 90 triangle is half of the equilateral triangle. Okay. So we know that this is going to be 1. This is going to be 1/2. Forgot to write 90 degrees here. Okay, while we add it, 30 degrees is pi over 6. 60 degrees is pi over 3. And 90 degrees, once again, is pi over 2. Okay. So from there, we can use the Pythagorean theorem to find the missing side. It's going to write it at x squared plus y squared equals to 1. We can use a and b, but since we're talking about unit circle, it's a bit nicer to use x and y instead. So we know that we have 1/2 here squared plus y squared is equal to 1. So that means that y squared is going to be equal to 1 minus 1/2 squared, which is a quarter. So this will be 3/4. So y is going to be equal to the square root of 3 over 2. So that's going to be on this side here. Okay. So the two special triangles then that are going to be important for the rest of trigonometry is going to be this special triangle on the left, the 45, 45, 90 triangle, and then the 30, 60, 90 triangle on the right. Okay, so let's see how we can combine the special triangle and what we know about the unit circle together. So we are given some degree measure here and also some radiant measures of angles. These are going to be rotational angle in standard position, and we are to find the point on the terminal arm that intersects with the unit circle. So for example, in the first case, we'll have the positive x-axis as our initial arm, and since the angle is negative 60 degrees, it's going to look like this. The numbers here included are 30 degrees, 45 degrees, and 60 degrees, which of course are the numbers associated with the special triangle from the previous page. So in this case, we're looking at negative 60 degrees. We have the initial arm and terminal arm. This angle measured here is going to be 60 degrees. So what we can do is draw a right triangle this way. And we will know the length of those three sides. Okay. That is to say, we know that the hypotenuse of this right triangle is going to be 1 because it is a unit circle, so the radius is 1. And because of the fact that it's a special triangle, we know that this angle here is 30 degrees. And we know that this side, the x value will be 1/2, using the special triangle from the previous page. And the y value will have the magnitude of root 3 over 2, but it will be negative because it is in quadrant number 4. So all in all, we're looking for the coordinates of this point here, right? The point on the terminal arm that intersects with the unit circle. And so it would have the x coordinate of 1/2 and the y coordinate of negative root 3 over 2. So once again, that is 1/2 and then negative root 3 over 2. Next angle is 270 degrees. So we're going to start with a initial arm once again, the positive x-axis, and 270 degrees simply points straight down. So in this case, we don't need the special triangle because there's only one point that really works here. This is going to have coordinate of 0 and then -1. So that's it for example B. Okay. Next, we have a couple of questions in radiant measures. The first one is -4, so this would be in quadrant number 4 once again. It looks kind of like this. And of course, pi over 4 is just 45 degrees. So also -45 degrees. And so we can use that special triangle, the 45, 45, 90 triangle. I'm going to draw this side here. And so the idea here is this is going to be 1, once again, just like before. The angles here are pi over 4, and this other angle is pi over 4 as well. So each one of the sides will be 1 over root 2 in magnitude. So the x value is going to be 1 over root 2, but the y value will be -1 over root 2. So 1 over root 2, and then -1 over root 2. Okay, next up is 7 pi over 6. So 7 pi over 6, we could convert it back into degrees. That would be 210 degrees. So if we were to draw that, again, it'd be here. So this one's a little bit different. We are looking for the right triangle still, and the only way to really draw a right triangle with the x-axis is to draw it this way, which means we're going to have to use the reference angle for 7 pi over 6, or 210 degrees. Just going to write that in here. This is 210 degrees. Eventually, we'll need to work with radians without relying on converting them back into degrees, but for now it's okay to change the measures into degrees if necessary. So in this case, 210. Okay, so we can draw here that the reference angle is pi over 6, or 30 degrees. And this other angle is going to be pi over 3. So the radius, or the hypotenuse of the right triangle, is still 1. This time the y value will be the 1/2 in magnitude, -1/2. And the x value this time is going to be -√3 over 2. Okay. So again, using the special triangle, that is pi over 6, pi over 3, and pi over 2. So -√3 over 2, and then -1/2. Okay, which makes sense because the point is in quadrant 3, so we expect both the x and y values to be negative there. Okay, the next question. This time we are given the coordinates of the points, and we are to find the angle. So these points will be on the unit circle. Okay. First one, we have √2 over 2, and then √2 over 2, except for it's -√2 over 2 and then √2 over 2. Since the x value is negative and the y value is positive, so negative positive, that means the angle must be in quadrant number 2. And since we have root 2 over 2, root 2 over 2, we know that the reference angle that's going to be involved is 45 degrees, which gives us this angle here. Now, it doesn't specify what the whether it should be in degree on or radian, so we're just going to answer it in both. So in this case, the degree measured is going to be 90 degrees plus 45 degrees. And again, we know that this is a 45 degree because of the reference angle. And we know that the reference angle must be 45 degrees because the root 2 over 2 and root 2 over 2 are associated with the 45, 45, 90 triangle. So that's how we can get 90 plus 45 for the angle measured, which of course is 135 degrees. So in radians, we know that 90 degrees is pi over 2, 45 degrees is pi over 4. So if we write this under a common denominator of pi over 4, this is 2 pi over 4 plus pi over 4. So 135 degrees is actually 3 pi over 4. Okay, so next question we have negative 1, 0. So if we were to draw that, it would just be a horizontal line. Since we start at the positive x-axis, but the point in question is going to be on the negative x-axis, so right here. So that means our angle then is going to be the 180 degree angle. Or of course in radians this would be pi radians. Third one, we have 1/2 and root 3 over 2. So the 30, 60, 90 triangle must be involved. And we also know that it is going to be in quadrant number 3 because both x and y are negative. So since the x value is smaller and the y value is greater, in terms of their magnitude, 1/2 is smaller than root 3 over 2, we know that the angle that's going to be involved is going to be 60 degrees. Right? Because if we were to draw the angle this way, and then we look at the resulting right triangle that we can produce this way, notice how that is the longer side, the y value is greater, the x value is smaller. So this must be our negative 1/2 here. This must be our negative root 3 over 2. Sorry, that's not the best root 3. Just going to write a little bit bigger. There we go. So that means that this angle is the 60 degrees, and this angle here is the 30 degree angle. It's a right triangle, of course. So the angle that we're looking at as a reference angle of 60 degrees, and it's in quadrant number 3. So that means we have 180 degrees plus the 60 degree reference angle, which gives us 240 degrees. And we can change this into radians by multiplying by pi over 180 degrees, which will give us 4 pi over 3. Okay. So, one more. Now, since in example D, both the x and y values are positive, we know that the angle is going to be in quadrant number 1. Oops, sorry about that. And we know also that the x value is greater than the y value, so the angle is going to be more flat. And we know that it's going to be the 30, 60, 90 triangle once again, because root 3 over 2 and 1/2 are the numbers for that triangle. So this is simply going to give us the angle of 30 degrees, or pi over 6. We could draw in the triangle as well, just like this. And we already know that this is going to be the 1/2 this way, and then the √3/2 this way, which makes this the smaller angle. This would be 30 degrees, and this would be 60 degrees here. Okay, so that's the idea. So as a quick side note, in some of the homework question, it does ask about what happens if we add 90 degrees to the angles that we have. So if we added 90 degrees, it will suddenly be in quadrant number 2. Okay, which is going to be here. And then the other piece of information of note is that the reference angle, so this is 90 degrees in between, so the reference angle on the other side is gonna have to be 60 degrees. So because of that, the triangle that can be formed there will be, again, another 30, 60, 90 triangle, but one is in quadrant number 2, so it would have negative x values and positive y values, and the numbers will be negative 1/2 and then positive √3/2. Okay, so the important information here is that it's still the same type of triangle. It's just the 30 and 60 switches with respect to whether they're associated with x or y. And so that's it for the unit circle and the special triangles and how are they related to each other. And that's it for today, so thank you for listening.